Hi guys, welcome to another Chelmer Value Maths tutorial. Mr. Gordon here, and we're just going to be looking at exercise 1F and then 1G. And I said in the previous video we were going to be looking at SIRS, but before we do that, let's just extend our knowledge of indices, because at A level it gets a little bit more tricky than the ones we were given at GCSE. So we can also, these are the rules that we mentioned in a previous video, and we're going to look at how we apply them when we've got fractional indices. So let's just jump straight in and check out some of the examples. So when we're dealing with normal numbers, just to recap the rules, how would you do something like this? Well, you've got to remember that when you divide powers, you subtract them. And you've got to remember also that it's 4 minus a minus 3. The divide sign kind of stands for a minus. So what's 4 minus a minus 3? Well, that's going to give me a plus 7. So it gets, it can get really fiddly with all the negatives signs included as well. Looking at fractions then, if you've got some fractional indices, which are quite common at A level, you've got to start getting used to dealing with these. You just follow the same rules really. So we're going to add together the powers. So we've got a half and 2/3 as our indices. We're going to add those together. So what's 1/2 added to 3/2, or 3/2? Well, it's going to be 4/2. If we've got the same denominator, so we just add the tops, we get 4/2, which can then be simplified. Obviously 4 divided by 2 is just 2. Looking at another example, when we're multiplying, this rule is when we multiply the indices together. One's in the bracket, one's outside. You can see it over here. This is the rule that we spoke about earlier. Then you just need to multiply. When you multiply a fraction by a whole number, you must remember that you only multiply the top part. If you multiply both numbers by 3, which is what some people like to do, then you're just going to get an equivalent fraction. You're not going to change it at all. You're not going to times it by 3. So all we do is we times the top number by 3, and that will end up giving us 6/3, which again we would simplify, and that gives us x squared. Another example here. Now, sometimes you will still have sort of decimal indices. At A level, if possible, I would recommend that you move away from decimals as much as you can. Fractions are so much easier to work with. In GCSE, at GCSE, we love decimals. They did a great job, and everyone was really comfortable with them. But at A level, I would recommend that you try and convert everything to fractions. It's such a much more natural way to work. So what we are up to here, we're dividing 2x to the 1.5 by 4x to the minus 0.25. So whole numbers first. What's 2 divided by 4? Well, 2/4 is going to simplify to a half. And then we're going to subtract these powers. So we've got 1.5. Remember, the divide sign is a minus, so 1.5 minus 0.25. Those two negatives in the middle are going to become a plus. So we're going to add the powers, those indices to get 1.75. So we've got our half here to the x to the 1.75. It's perfectly acceptable to write it like that, but I would recommend that you change it into fractions. Like I said, the more work you do at A level, the more you'll start to realise that actually fractions are your friends, okay? So, some different things here. We're looking at fractional powers with numbers. And we spoke about this earlier. We said that the bottom number is, you can see it down here, is the root. So we have to take the second root, which is more commonly known as the square root. That's your normal one, square root. So that becomes the square root of 9, which is 3. And we would raise it to the power of the number on the top, which is just a 1. So it doesn't change it at all. 3 to the 1 is just 3. If we've got 64 to the 3rd, well, that's not a square root anymore. We've got a 3 on the bottom, so it's going to be the cube root. And the cube root of 64, what number times by itself 3 times is going to give you 64? Well, the answer is going to be 4. Okay, and again, we'd raise it to the power of 1, but that won't change it, so we just leave it as 4. Now, this one's more interesting. We've got a 2 on the bottom and a 3 on the top of the fraction. So the bottom is the root, so what's the square root of 49? That's going to be 7, and then we'd have to raise that answer to the power of 3. So what is 7, if you like, to the power of 3. Well, it's on your calculator. Well, you see one, you can't use a calculator. You have to do that by hand. You should learn your cube numbers. I would recommend learning your cube numbers. And that's 343. 7 cubed is 343. 25 to the minus 2 over 3. So I prefer to sort out the numerical value first and then address the minus part. So let's do the square root of 25. It's going to give me 5, and then we're going to raise that to the power of 3. Now I know 5 cubed is 125. So the value is going to be 125, and what does the minus do? Well, we said before, didn't we, that it's just going to give you the reciprocal without the negative sign. So it would be 125 is the number we've got, so it would be 1 over 125. So you can see that other people like to do it the other way around. They address the minus sign first, so they put the 25 to the 3 over 2. They do the 1 over bit first and put it on the bottom, and then they work out the value. Okay, either way is absolutely fine. Okay, carrying on, looking at another tricky sort of idea. We've got a fraction here raised to the power of minus 1. Well, we could just follow the same rules as before. Let's put this to the 1 over. So we've got 1 over, the minus sign makes it the reciprocal, so 1 over 2/3. And then we've got to kind of address this. Now, if you've got a fraction on the bottom of a fraction, what happens is this 3 is going to come back to the top and will multiply the 1. So you kind of push it off the bottom and it comes all the way around and comes back up. And you can think about this if you did 1 divided by 2 over thirds. Well, from the GCSE, we were taught to flip the dividing fraction upside down and then multiply it. So if you did 1 times the flip of this, so the reciprocal, 1 times 3 over 2, you'd end up with the same result. You'd have 1 times 3 over 2 is just 3 over 2. So again, that 3 would drop off the bottom and come back to the top and multiply whatever is up there. Okay, so try and bear that in mind. And this one here, now with this example, we've got the power of a third is going to be applied to both the top and the bottom. Okay, so this means it would be 1 to the third and 8 to the third. You remember the rule when you've got powers inside the brackets, you multiply them with the power outside. Well, what's the power on the 1 at the moment? Well, it'll just be 1 to the power of 1, but we don't write the 1 in. And the same for the bottom number, 8 to the power of 1. Again, we don't write that number in. So we'd multiply those together and you'd have 1 to the power of a third and 8 to the power of a third. Well, what does that mean then? If you've got the power of a third is the cube root. So what is the cube root of 1? That's just going to be 1. What's the cube root of 8? Well, that's going to be 2, because 2 times 2 times 2 is 8. Okay, so we'd simplify it, we'd do them separately and we'd simplify it in that fashion. Okay, so moving on to our surds, so surd manipulation. How are we going to be able to simplify surds? So some of the rules to start off with, you can, if you times, so the root A times root B can be represented as root A times B, so you can times those numbers together and keep them underneath a square root sign. So again, that is just a more simplified version of that. We're not using the times sign. In algebra we don't, do we? We put things next to each other, so that means the same as the rule above. And the same for division. You can think of this as if you divide two surds, then you could just divide A and B and put the result underneath the square root sign. It will make more sense with some numerical examples. So let's try and simplify a surd. So simplify the following. Root 12, okay? How are we going to simplify root 12? Well, think about what type of numbers are going to help us out when we're simplifying if we're working with surds. We've seen surds before at GCSE, and also before that, you know, the very first surds, well, the very first numbers that we look at underneath square root signs are square numbers. And why are they going to be useful in this topic? Because we can work them out. So if we can think of a square number and another number, then we can always simplify the squared part. So what do I mean by that? If you're trying to simplify root 12, you can use these rules here to rewrite it. And we could rewrite root 12 as root 6 times root 2. I mean, that's the same as 12, isn't it? Following this rule here. But what would be the point? Because we can't simplify that down. There are no square numbers to then be simplified. We're better off writing it as root 4 times root 3, because the root 4 is the part that we know. Now, whenever I teach this to students, because they're doing something slightly new and complicated, they forget that they know what the square root of 4 is. It amazes me how many times it's left unsimplified. So don't forget to simplify it. So instead of having root 4 times root 3, we'll simplify that to a 2, and we'd have 2 times root 3. And we just write that as 2 root 3. That's without the times sign in between. That's good conventional notation. So let's have a look at this one. How could we simplify this? I mean, you could pause the video and have a go at this, and I'll walk you through the solution if you've had a go at that. So let's start by trying to simplify the surd on top. What square number goes into 20? So we could rewrite the top as, we know 4 goes into 20, so we have root 4 times root 5, because that gives us the same as root 20. And then we could simplify the squared part, so that the 4 is a square number, so let's simplify that to 2. When we do that, we get 2 root 5 on top, divided by 2. Now, this is just like algebra. What would you do if you had 2x divided by 2? Well, then you would just give the answer as x when you divide the 2's and cancel them out. So we're going to do that with surds as well. We're going to divide the number part, so you've got 2 divided by 2, which ends up just being 1. So you just end up with the 1 times root 5, which is just root 5. So why is this helpful? Well, when you're trying to simplify things like this, then it's if you want to add surds together, it's got to be like terms. So it's very much like algebra. You need to have sort of, if you wanted to add some root 6's together, you'd have to have certain different amounts of root 6's. You can't add root 6's to root 24's. So in this current form, this is unhelpful. So we can use this idea of simplifying surds to then solve this problem. So we've got 5 root 6. Now there's no square numbers that go into 6, so I'm going to leave that as it is. And let's look at this one. We've got minus 2 root 24. Now I know that 4 goes into 24, and it would be root 4 times root 6 that would make 24. So that's helpful because we want root 6's at the end of this. So let's have a look. If we wrote it like this, root 4 times root 6, remember we can simplify the root 4. That would become a 2. You'd have minus 2 times 2, which is going to be minus 4 root 6. And the last term is, we try to look for the largest square number that goes into 294. Now, if you're unsure, a clue would be to think of a number maybe close to 294, which is 300. And we're trying to get root 6's, aren't we? So what goes 6 times what would make 300? That's 50. And then I would say, look, I'm short by 6. So it would be 6 lots of 49. If I took 1 off of each 50, that's how I would think about it to work out that. It's not completely obvious to most people that 49 times 6 is what you're after there. But try and look at different square numbers and see which ones go into 294. I know that's not an easy simplification, but believe me, in time it will become easier. So then we just need to simplify our square numbers, and then we can add the different bits together. So this has now become 5 root 6. We've got our minus 4 here from minus 2 times 2. And then we've got our 7 from the root 49. So we just add them up. What's 5 root 6's? Take away 4 root 6's, add 7 root 6's. Well, in total, if we did that, we'd end up with 8 root 6's. Because 5 take away 4 gives me 1. Plus 7 is going to give me 8. So I hope that helps, guys.